So we're going to be given a relation, and we're going to be asked, is this relation a function? So if you're given the relation in the form of a set of ordered pairs, what's the rule? How do you know? What are you looking for? The x's cannot repeat. So the rule, to be a function, the x's cannot repeat. An example, determine if this relation defines y as a function of x. The first one, you have the set of ordered pairs 8, 4, 3, negative 1, 5, 4. Is that relation a function? Yes. This one is a function. Look at your x's. 8, 3, 5. Do you see the same x listed twice? No. So that's a function. Do you care about the y values? That y value is listed twice, but do we care? No. All right. Second question. Negative 3, 2, 9, 5, 1, 0, negative 3, 1. Is that relation a function? No. So we're going to say not a function. And I'm going to go make myself a note and say that repeats. Negative 3 repeats. That's why it's not a function. Okay, what if the relation is given to you in the form of a graph? How can you look at a graph and tell whether or not the relation is a function? Well, you have what's called the vertical line test. Remember what that says? If any vertical line crosses the graph more than once, it's not a function. So right here, no. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. That's the rule. No vertical line can intersect the graph in more than one point. An example, determine if the relation defines y as a function of x. Looking at this graph is like a V that's opening to the right, correct? That's a relation. It's a set of ordered pairs. Does that relation, is it a function? If I were to draw a vertical line, say right here, how many times does it intersect the graph? Once. So does it pass the vertical line test? What does the vertical line test say? No vertical line. So if I can find another vertical line, let's say this one, how many times does it intersect? Twice. Okay, I don't care about that vertical line. This vertical line intersects it twice, so guess what? This is not a function. If you can find one vertical line that intersects it more than once, it's not a function. Letter B, is that a function? Yes. No matter what vertical line you draw, how many times are you going to pass through it? One time. So I'm not even going to put that on my graph. I'm just going to say, yes, this is a function. C. Okay, be careful. What's the value that's really at question here? What x value? X equal negative 2, right? And I'm going to look at this graph. There's a filled-in circle here, and it goes this way. There's a filled-in circle here, and it goes this way. The only value I'm really concerned about is right there. If I draw a vertical line, how many times will that vertical line intersect? 2 times, right? So this is not a function. Now, the other day, somebody said, well, what if And I think I talked about what if in this class, right? You totally changed the problem. They said, what if one of those had been an open circle? So it looked like this. Would that be a function? Yes. Because the only place that really concerned us was right here. It would cross once here. Would it actually cross the function there? No, because that's a hole. So that, letter D, would be a function. Okay, now what if the relation is given to you in the form of a mapping? How do we know if the relation is a function? The rule, again, the x's cannot repeat. I'm going to do a visual rule for you. If it looks like this, if the x value is going to two different y values, that's not a function. So quickly looking at this first example, do you see any x value going to two different y values? I see 1 going to 2, that's okay. I see 3 going to 2, okay. And I see 5 going to 4. Do any of these values go to two different y values? No. So that is a function. Do we care if the arrow looks like that? If the two different x's go to the same y? We don't care. That still is a function. That's okay. So let's go look at the second one. Is this a function? Yep, sure enough. Okay, what if the relation is given to you in the form of an equation? For example, y squared equals x. How do you know if that equation represents a function or not? The rule. To be a function, you have to be able to solve for y explicitly. Must be able to solve for y equals something. And actually that something has to be just a function of x. Some things to notice on your y. What's the power of y up there? Y to the first power, right? You can't have a y squared. You can't have a y to a power other than 1. You have to get it into a y equals. Knowing that, this first example here, y squared equals x, is that going to be a function? Y is a function of x. Can you get y equals something? Well, if you try to, and you take the square root of both sides, wouldn't you get y equals plus or minus the square root of x? Isn't that how that works? So how many equations do you have over here? Y equals the positive square root of x and y equals negative square root of x. There's two equations there. That's not, this is no, not a function. For those of you who have seen, have done parabolas, this is actually a quadratic. It's a parabola that opens which way? To the right. Y squared equals x. So looking at it graphically, would that pass the vertical line test? So that's not a function. Okay, letter B, x squared plus y squared equals 25. Is that a function? And right away I look and see, okay, I have a y squared. That's not going to be a function. This is actually the equation of a circle with center 0, 0 and radius 5. Remember that? Would the graph of a circle pass the vertical line test? No. So a circle is not a function. The last one, y equals the absolute value of x plus 3. Is that a function? What's y? What power is y raised to? The first power. I've got it in the form of y equals something, and that something just has x's in it. So is this a function? Y is a function of x. Yes, that is a function. And the graph of that one is a v that's been shifted to the left 3. So it looks like this. Would that graph pass the vertical line test? C is a function.